In this video, I want to look at how to find the area of triangles. And I want to do this using progressively more sophisticated methods. Let's start by supposing I have this triangle and I have my grid that's all 1 unit by 1 unit squares. The most primitive method for determining its area is to count how many 1 by 1 unit squares it takes to cover the shape without gaps or overlaps. This is going to require squares to be cut apart and pieces to be moved and recombined with other pieces to make as many full squares as possible. And there are a few different ways that we can do that. The first way is we can move smaller pieces. We can take this portion of a piece and move it down to this block, this portion of a piece and move it down here, and this portion and move it down here. And if we were to do that, this is kind of the picture we would end up with. We still see our triangle, but we took this piece right here, and it is now this piece shaded. This piece right here got moved down to be shaded here, and this piece here. So now we can count 1, 2, 3, 4, 5, 6, 7, 8, 9 units squared for the area of this particular triangle. Another more advanced method would be to cut the triangle in half here and take this portion and move it down. In this case, we would take these top 3 portions and move them down here so that I can still see this would be 9 square units of area. Our final method would essentially just finish out this rectangle so that we have half of the area of the rectangle. We can see that the rectangle is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 units. And like I said, we need half, so we'll have 9 square units for its area. And we can use this method right here of drawing out the full rectangle and then taking half of it to generate our actual formula for a triangle, which is 1/2 base times height. So before I discuss this formula a little more in depth, let's define exactly what the base and the height of a triangle mean. Let's start with the idea of the base of a triangle. The base of a triangle is denoted by B, and it can be any one of the 3 sides of the triangle. And that would give us the base of the triangle. Once we choose a base, the height can then be determined. The height is denoted by H. The height needs to be perpendicular to the base, and it needs to connect the base or an extension of the base to the vertex of the triangle that's not on the base. So let's look at a couple of examples. Here I have a triangle that's determined by ABC. Let's suppose I pick this side here to be my base. In that case, I'm going to draw a perpendicular line coming from my point B and intersecting this base, and the height of that will be the height of the triangle. If I look at the exact same triangle, and this time I want to define this side to be the base, then I would extend out this bottom side so that when I draw my perpendicular, it intersects an extension of the base. So this is what we mean by connecting the base or an extension of. We might have to extend out the line segment. So this would be my height H. No matter which side is chosen to be the base of the triangle, we still have a single formula that gives us the area of the triangle. 1/2 base times height. So if we know a base is 5 inches long, and we know the corresponding height is 3 inches, then the area would be 1/2 times 5 times 3 square inches, or 7.5 square inches. The main thing for using this formula is to note that it's very important for the base and the height to be described in the same unit. So for example, here they're both in inches. They could both be in feet or both in centimeters, but if one is in feet and one is in inches, we must convert to a common unit before calculating the area. Why exactly is this formula valid? To show that, I'm going to start with a right triangle. We're going to let this be base and this side be the height. Then what I'm going to do is I'm going to take an identical copy of this triangle, this one here, and I'm going to take it and flip it over and attach it to this triangle so that this side, that is neither the height nor the base, matches this side. When I do, I get a rectangle that has one side H and one side B. So the area of the rectangle will be B times H. So the area of the triangle, since I had two triangles that made up the rectangle, it would be half of the area of the rectangle. So this is great for right triangles since putting two of them together will give me an actual rectangle. But what if I don't start with a right triangle? Let's consider this triangle here. I have my base and my height indicated, and I want to try to figure out why the formula works. If I were to take one of these and flip it over and attach it the way I did before, then it wouldn't give me a rectangle. So how would this work? Well, I am still going to start with a second copy of the triangle. And I'm going to take this half, flip it over and attach it here, and take this half and flip it over and attach it here. So if I color code this, I can see my main triangle down here at the bottom of this rectangle. This piece here that's on the left comes over here. And this larger piece on the right comes down here. So we do have two full copies of the triangle here. And this is still a rectangle, so the area of the triangle would still be 1/2 base times height. There is one more case to consider, a triangle like this, where the height actually goes on an extension of the base. This time, if I put two of my triangles together and try to make a rectangle, I have this extra area on both sides that comes from this area here. That's not actually in the triangle. So I want to do is figure out how this formula still works. So the base is from here to here. So let's call this other value A. That'll work the same on the top. So what we really have for this rectangle, so I'm going to use an R for area of rectangle, is A plus B times H. So this is AH plus BH. However, if we remove the shaded part, the extra pieces, well, that would be the entire rectangle minus, this is a right triangle. It has area 1/2 AH. Same thing here. So we would actually be subtracting out an AH. And that would give us that the entire area of the rectangle without the shaded part, so just this double triangle piece here, would be BH. So the area of the triangle would be half of that.